Alright, what I have here is the finishing part of the notes for 4.3, and then also I gave some problems dealing with a worksheet dealing with Riemann sums on what you might see on the AP test, and I'm going to approach both of these in these notes. And if you take a look, here we have definite integrals, and we're going to actually apply most of these definite integrals when we get to section 4.4. There are some that hopefully seem somewhat obvious. If you take a look at the first one, if a and b are the same value, there's no space in between them, so there is no area. And that's the idea behind this, is that when you integrate from a to a, you get 0 as your answer because there's no area in between them. This one we're going to see later on when I get to 4.4. I'm going to do some problems like this. You actually see a problem like this in the AP questions for 4.4, and I'll address them to see if anybody's actually paying attention to any of these videos, because it would be helpful in one of the problems on the AP section for 4.4. And this is saying is if I'm integrating and b should be my largest number and a should be my smallest number, but in this case they're in opposite locations. Well, what you want to do is reverse them, but if you do that, you have to multiply by the negative, because you're going in an opposite direction than what was the integral states. So make sure you multiply that by a negative, and again we'll look at that when we get further on in 4.4. Here is saying that if I have some value, and again we'll see this in 4.4 especially when we get to a point of absolute values. But let's say I have a graph that looks like this. My graph comes down and touches the x-axis and then bounces back up and comes back to here. So here's my a, and right here is my b. Right here I have a c value. Well, I'm going to integrate this. C is between a and b, and I'm going to integrate between a and c, the f, and then I'm going to integrate between c and b, the f, and add those two areas together for the complete area. And again, you'll see that more when we get to 4.4 and talk about absolute value. This says if you have a constant that you're multiplying the function by, you can bring it out front. I think that's pretty self-explanatory. And here, if you have two functions and you're adding and subtracting them, you can break them up as two separate integrals that you're adding and subtracting. So those are somewhat similar to the summation rules that we had, so especially these particular cases. So I'm hoping anyway, they're not too complex. Okay, here's a very common problem you see on the AP test during Riemann sum. Notice it says a right Riemann sum. That means your rectangles are going to have a right corner. And what I do to do this is I plot the values. So here's my y-axis, here's my x-axis, and I'm just going to make rectangles. And so I have 0, -10 right here. I have that point. I have 2, -2. Let's go 2, 4, 6, 8. So 2, -2, 4, 6, 6, 8, and 8, 14. Okay, and now they say right. So usually I start over here with the right, and I'm going to draw my line straight down from this right corner. If it was left, I would draw it down here, but it's more my right, and then I'm going to come over here to the next interval and draw down. I'm going to start here, draw my interval, go down. Start here, draw my interval, go down. Start here, draw my interval, and go down. So I have 1, 2, 3, 4 rectangles that I have area. This one will be negative. And so this length right here is 2. This length here is a -2. So I have a -4. This length right here again is 2 because it's between 2 and 4. And this height right here is 6, so I have 12. This is 2. This height here is 8. So I have 16. This height is 2. And I have here 14. So I have 28. So my area is going to be a negative 4 plus 12 plus 16 plus 28. So the area under this differentiable function f is going to be, if I add these together, I get 8, I add this 16, I get 24, and I add the 28, and I get 52. So I have 52 units. Now they may be square units, it depends what the x and f of x values are, and we'll be talking more about that later.